Okay, so gradient. To find the gradient of a straight line, you need to either rearrange the equation of a line into the format y equals mx plus c, use the gradient formula, m equals y2 minus y1 over x2 minus x1. Both of these are still completely valid for the higher course, but the new formula that's introduced for higher is m equals tan theta. And theta is the angle between the line and the positive direction of the x-axis. So it's this angle going up to the line. So you can see we've got a positive gradient and we've got a negative gradient. And that makes sense because if we think about our cast diagram, tan is positive in this quadrant where it's an acute angle, and tan is negative when it's in the second quadrant for an obtuse angle. So let's look at an example. We want to find the gradient of the line in this diagram. So we've got a line there with an angle of 27 degrees. So we're going to write down m equals tan theta. And then we're going to substitute in the angle of 27 for theta. Now make sure your calculator is in degrees mode. And if we put that in, we're going to get 0.51. Right, another example. This time we want to find the angle that the line y minus 3x minus 5 equals 0 makes with the positive direction of the x-axis. So the first thing we're going to have to do in this one is we're going to have to rearrange that equation into the format y equals mx plus c so that we can get the gradient from that line. You cannot just take the coefficient of x straight out of that equation because it's not in the correct format. So we've got y minus, I have to say it's very difficult to draw with a mouse, minus 5 equals 0. And then we're going to add the 3x and the 5 to the other side, giving us a gradient of 3. Now, if we had a coefficient of y, we would obviously have to divide by that. So for this particular line, m equals 3, and if we wanted to work out what the y-intercept is, then we would have to say that it is 5. So then, thinking about the fact that m equals tan theta, and that's going to equal 3. So we know to work out an angle, then we need to use the inverse or the arctan. So we need to press the Shift tan button on our calculator. And then type in the number 3. And again, make sure your calculator is in degrees mode. So Shift tan 3 gives us an angle of 71.6. 71.6. And that's the angle that our line is making with the positive direction. So imagine that our line's going at a gradient of 3, it's cutting through the axis at 0.5, and it's making an angle of 71.6. Now, it's asking us then to state the size of the obtuse angle that the line y minus 3x minus 5 makes with the x-axis. And again, we're going back to thinking about our cast diagram. So if we've got this line that's going up like this at a gradient of 3, and we've already worked out that this angle here is 71.6, and we want to work out, let's choose another color, what this angle here is. And we know that in the second quadrant, we are going to do 180 take away 71.6. And that is going to give us an angle of 180 take away 71.6, 108.4. Right, so final example, we have to think about our parallel lines here. So we have an angle up here. We know that if we were to draw a parallel line coming up like parallel to the x-axis going through the base of that point, we can work out what this angle here is using our m equals tan theta. We don't have to rearrange our equation because it's already in the right format. So we know that m equals 4. So we can work out our angle by doing arctan of 4. And the arctan of 4 happens to be 75.96. So we'll go with 76.0. Now, we want this angle up here. Now let's change the color again. We know that this angle here is a right angle. So to work out theta, we're going to do 90 take away 76, and that gives us an angle of 14 degrees. So now if you want to go and try some of the questions in exercise 1.3, in the booklet, it's not on page 5 in the booklet, that's the page in the textbook. Questions 1 to 3 and 5, 7 and 9 would be the ones that you would want to target. Good luck, and if you need any help, just let me know.